theory of most of the part we have discussed, and we have taken all of the conventional problem whatever came to ES conventional as of till now. So till now we have did only those problems. So for today I have I thought like we should do some. I'm audible, right?
Yes, sir.
Yes, sir.
Okay. So for today we will be doing the gate previous year problem. So I today I took the like latest problems that came. So in 2-3 days we will finish all the gate problems. Okay. So after that I would be thinking like we should go for the next thermal part like RAC IC, and that part would be finished in 3 to 4 classes. Okay. So
Sir, previous session question जो homework answer.
okay. 1 minute. So after the class we will you just let me know the question. I will show the questions and let me know the answer. Huh?
Okay.
So from I say like every one of you have calculator, right?
Yes, sir.
Okay. 1 minute, I see recording is there or not. Yeah, fine. Okay, screen is visible, right? Oh no.
No, sir.
Okay.
No, sir.
Now visible.
Yeah. Yes, sir. Yeah, now it's
So some there are theoretical questions I have took because these questions are from I think 2021 or 2022. Huh? So those I would say like to quickly answer. So first for the first problem, anyone just read and tell. Who knows? Just raise hand. Okay. So in chat box can you type for like for theoretical answer we would go like that only, alright? From next class I would try to raise poll. Till now, as of now, you just type the answer. So then I will say like something. If I need to ask, then I will ask. If anyone don't know, then let me know. I will tell. So what would be the answer? Okay.
Energy volume.
So it is saying like in non-flow process means closed system. 1 to 2 by perfect gas, heat interaction is equal to the work interaction. So can anyone let me know here what is the difference between this and the first law of thermodynamics? Here it is saying del Q is equal to del W. Sorry.
So first law of thermodynamics state that heat interaction in a cycle is equal to the heat interaction in that or is equal to the work interaction in that cycle.
And
But here cycle is not there.
it is for process only, right? So this is the difference. Del Q is equal to del W. So that we need to so. So here what is the first law of thermodynamics? Del Q is equal to del U plus del W. So here it is saying like it should be 0. When it should be 0? For isothermal, right? What is the value of del U? mCv delta T, and delta T is T2 minus T1. So it would be 0 only when if T2 is equal to T1. Is it correct or right? Is it okay to everyone, right?
Yes, sir.
So that keep in mind. It is for the process it is asking. So if it is written here cycle, then for all it would be correct, right? So this is quickly answer. Which one? This also last year I think it has come. So here which one? First mass is intensive or not? Okay.
Not, sir. It's density.
Only density, right? Here for this type of problem, you for intensive extensive means ratio of two extensive properties also intensive property, that keep in mind. Okay, anywhere it comes like, so you can put like two ratio of two intensive property is two extensive property is intensive. So just quickly this problem. This is, you have to find the net work done. This is 2 marks problem last year. What would be the just exactly read the words what is written here. Here only you would be committing mistake. Just try 2 minutes try, then I will discuss. What? Anyone asking anything?
T2 is equal to T1.
Oh, you are asking for the first question, right?
Yes, sir.
So what are you asking there? You are telling or asking something? Actually, I missed your voice in between. You are telling, right? T2 is equal to T1, or asking how it is? What?
Yes, sir. Yes, sir. How?
Okay, okay. So in question what is written, like heat interaction should be equal to the work interaction, and by the first law of thermodynamics, del Q is equal to del U plus del W, right? You know
Yes, sir.
this one, you right? No, no, right? So when it will be del Q is equal to del W, when del U will be 0, correct?
Yes, sir.
And we know the formula of internal energy is del U is equal to
MCV delta T.
m CV delta T, and
Yes,
m
sir.
cannot not be 0 and CV also not 0. So
Yes,
delta 2 delta T should be 0. And what is delta T? T2 minus T1. So if
is equal
T2
to 0.
so T1 should be T2, right?
Yes, sir. Yes, sir. I got.
Okay, fine. So
So if we say cycle, then what is the difference?
for cycle, for all processes, it would be correct. Means heat interaction should be equal to the work interaction. Because for cycle, anyhow you are starting from this place and you will reach here, finish the cycle and come here. Again you are reaching the same place, right? Getting or not getting?
Yes, sir.
So if you are reaching here, so anyhow T2 would be equal, like final T is equal to the initial T. So it would be 0, right?
Okay, sir.
So for all that time, for all it would be 0. If it is written like here cycle, then all 4 would be correct, because MSQ also coming now, so you keep in mind that. So you try this question and I will start.
Sir, 409 kilojoule
Plus or minus, that I want.
plus, sir, absolute value.
So it is compression here, right? Because here it is right, like initially pressure is something 110 and volume is 5, and next volume decreasing, so pressure will be uh,
252.7.
hmm. Okay, suppose this is the first point and this is the second point. Here pressure is how much? 110.
252.7.
P2 and V2 no, right? V2 is how much? 2.5. So how many of you done this? 1 minute, I need to see. Anyone have done? Then type the answer. So I will start in that 10 seconds then. Okay. So what is the net work done formula? Anyone can tell for the closed system? This is the n here n is given. So polytropic index is given, right? So we have to write formula for that. Formula is P1 V1 minus P2 V2 by
N minus 1.
n minus 1. So P1 we knows, V1 knows, V2 we knows, and P2 we don't know. So how you will find the P2? Anyone?
P1 V1 की power n equal to P2 V2 the power
Okay,
n.
I am writing whole formula here. Anywhere anything needed, you can take that. Okay, P2 by T1 by P2 by P1 to the power n minus 1 over n is equal to P1 by P2 to the power. What would be here? N minus 1. Okay. So here we know the V2 and requires P2. So we will collect these two terms. Okay. And n already given here 1.2. So after calculate the P2, what would be the value of P2? You know V1 is 5, V2 is 2.5, P1 is 110. Huh? And n is 1.2. So let me know the value of P2. Hello.
Sir, 252.7.
Anyone other?
Yes, sir. 2.7 and 4.
Okay, fine. So P2 now we know P2 and V2 all we knows. Huh? Now we will put like so what would be coming the value of work net work done. Hello. Put this P2 here. P2 we know now. V2 also know. P1 also know. V1 know. And we knows. What is the value of work done coming?
Minus 408.9.
Minus 408.9 kilojoule, right?
Yes, sir.
So, but here you keep in mind you cannot put this, right? Otherwise, question would be wrong because here directly it is written like find the absolute value of work done. So, absolute means you have to put only the magnitude here, whatever the magnitude of work done. So, just put the mod of this and whatever value it will come, it will be the answer. So, these small mistakes keep in mind, okay?
So closed system is taken since due to the non-flow process.
Where?
Why it was taken closed system is due to the
No, no. I
non.
actually in question it is directly written in the closed system like that. So I here I haven't typed everything. So I just put the value. I want to keep in like more. My aim is to put more focus on this absolute value. Huh? So
Okay, sir.
because it is compression process, so logically also it should be negative because for the compression you would be providing the work. Huh? So we are going to put work on the system, but here we have to write the answer in that in only magnitude you have to write. Huh?
Okay, sir. So if it is given non-flow process, then can we does that imply it can be a closed system?
If it would be non-flow, then what would be the formula of non-flow process? Anyone remembers? Hello.
Oh, please repeat the question, sir.
Same
For
question.
steady flow process will be used dq is equals to dh plus dw.
Okay, that would be used, but that is most generalized equation, steady flow energy equations. But for the reversible process, also one equation is there. Na? I told it. W minus
vdp
VdP
integral.
minus integral minus
Right.
VdP. And these formula how we found dw is equal to VdP. Sorry, PdV. Right? This for closed system how we found this would be the PdV. So when we integrated this, what formula we have got for the polytropic? Anyone remembers that? I am asking.
Sir, n by n minus 1 into P1 V1 minus P2 V2.
Just put this. If it directly written like it is for the reversible process, and you find the work for the open system, and these data you have given, so that time you have to use this formula. But it is not so here, so we have gone with this. Okay. Any doubt? Actually, I have told the difference between this formula and that steady flow energy equations also in one of class, right?
Yes, sir.
Anyone remembers or not? Hello. Okay. So this is also simple question. Just try once and let me know the answer. It is simple equation. 1 kilogram of air initially at a temperature of this expands reversibly at a constant pressure. Simple constant pressure process until the volume is doubled. Gas constant is this, the magnitude of work transfer. So simply it is asking for that. This is constant pressure process PV, and you have to this V1, and this is 2 times of V1, and P I think it is given or not. No, P haven't given. So you have to find the magnitude of work transfer. Here also you have to keep in mind, like magnitude they have asking. Huh? So anyone did?
Yes, sir, done, sir.
Uh,
114.8 kilojoule.
yeah, it is very simple, right? Here pressure is also not given, volume also not given. So, but what is the formula of work done? W
MR T2 minus T1.
P, actually it is for constant pressure process is P V2 minus V1, right? But also we can write P2 V2 minus P1 V1, because P2 is equal to P1, correct? And by the ideal gas equation also we can write M R here T2, and P1 V1 would be how much? MR T1. So it would be MR T2 minus T1. We know the value of M1. R also knows. We need the answer in kilojoule, so we put R in kilojoule. So 0.287. What would be the value of T2 here? T2 we don't know,
800.
and but we don't know here. Na? T1 we know T1. This is in degree Celsius. We convert into the Kelvin, so it would be 400 Kelvin. So 400 Kelvin. But here no for constant pressure process, volume is directly proportional to temperature, right? So here volume is getting doubled, so final temperature will also be get doubled. So T2 would be 800. Initial one is 400, so it would be for 800 Kelvin. So simply take this value and put here 800. So just multiply 0.287 into 400. So how much it will be coming? 114.8, right? These are very much easier than whatever we are doing until now, right? So you can simply very quickly you can solve. If anyone having doubt, so you can stop me, or I'm going much faster pace, then you can also stop me, right? Should I stop or go forward?
Go for it.
So just try this question. I will give some hint, then we'll start. Huh? So for an ideal Rankine cycle operating
Previous
between,
slide.
huh?
Previous slide.
What are you saying? Oh, previous slide. Okay.
Okay, sir.
So Rankine cycle, I will let you know. This is the Rankine cycle. TS. Oh. this is, let's suppose this is the first point, this is the second, third and fourth. So this is the our boiler pressure or higher pressure, we can say PB, and this is our condenser pressure, so PC we can say, and this is the work done from the turbine, WT, and here we would be giving the work to the pump. What is the work of aim of the turbine? To achieve expansion of the fluid, and we get the work, and here we are increasing the pressure of the liquid by the pump by giving the work. So what would be the net work done in the turbine? WT minus WP, means whatever we are getting from the turbine and whatever we are giving to the pump, we subtract and get the net work done. Okay, so because actually that in the power plant, so I haven't taught, so that I told. And so now start, anyone can start, and let me know what is the answer. Now I have given hint. If anyone having doubt, then let me know, right? I will ask, I will let you know what how to, what are the problem there. So what is the network done?
900.
For turbine it is 1 minute. For turbine it is 903 kilojoule per kg, and for work pump we have to give 3 kilojoule per kg. So net we are getting 900 kilojoule per kg, and we have to find like what is the specific steam consumption. So anyone can define what is the specific steam consumption?
Mass required to produce a 1 kilowatt, matlab 1 kilowatt hour of power of energy.
Here it is asking for, they are asking for kilowatt hour, then you can say for kilowatt hour. Also you can say like energy mass of the steam required to produce unit power, that also you can say. So here they are asking how many kilograms of the steam we required in order to produce the 1 kilowatt hour energy. So simply, you know, like in 1 kg we are getting 900 kilojoule. So in 1 kilowatt hour how many kilojoules are there? Anyone knows?
Sir, 3.6 3. 3600
Kilojoule. Also you can easily find like 1 kilowatt into hours, kilowatt, and multiply the seconds here. 1 kilowatt means 1000, and hour means 3600, so that much of joules, convert that to kilojoule, it will come. If 3600 kilojoule. So from here you can see like in 1 kilogram of steam you are getting 900 kilojoule of energy, and so if you require 3600, then how much kilogram of steam you will need? Simply unitary principle you can apply. So one kilogram of steam gives 900 kilojoule. So for 3600 kilojoule, it would be 3600 by 900, right? It would be the 4 kg. Anyone a problem? Then I will explain, otherwise I will come to the next problem.
Explain, sir, once.
Okay. So Rankine cycle you know, right, or not? Should I explain this? You can clearly say. If you don't know, then say no. I will tell.
Yeah, sir, we know, sir.
Okay. Rankine cycle is the ideal cycle in order to produce the work in the power plant, right? So our aim is to produce, means achieve this cycle, but actually there are some losses and all. So in that cycle there are 4 processes. One, this from 2 to 3, 1 to 2, it is pump. In pump we used to increase the pressure of the lower liquid to higher, and from 2 to 3 we used to give the heat. From 2 to 3 it would be the boiler, and we would be providing heat to this, and it is expanding here, higher pressure, higher volume. And now if now we are whatever we are work done, we are getting the from higher pressure, higher volume, means here. And now we will expand it. Expand, when expansion will happen, then it's also means pressure decreases and volume also will increase. So here it will come, and this work done we will be getting. That I actually made wrong, because here it is the open system, so we will be getting here in this axis minus VDP. So in turbine we will be getting the work done, and also here condenser would be there, so we will condense that and again repeat same process. So here you have to simply find the net work done. Net work done would be the whatever work done you have got from the turbine, and this would be the positive because you are getting, and here in the pump you would be providing work to the pump. So net work done would be turbine minus pump. So net work done for the turbine it is given 900 kilojoule per kg, and for the pump it is given 3 kilojoule per kg we have to give. So what would be the net work done? 903 minus 3, right? Hello.
Yes, sir.
So 900 kilojoule of work you are getting from 1 kilogram of steam, because here what is turbine 903 kilojoule per kg, means in 1 kilogram of steam you are getting this much work. And for in order to compress 1 kg of the this one stage liquid to the 2, we have to give 3 kilojoule. So in 1 kg this much work you have to give, and net would be this much. So they are asking for a specific steam consumption for the 1 kilowatt hour. In 1 kilowatt hour we know 3600 kilojoule. So 1 kg gives 900 kilojoule of energy. Then so for 3600 how much kilogram of steam you needed? 4 kilogram. That's all. Okay.
Okay, sir.
So did we assume that it's for 1 kilogram of oils?
Where?
Kilogram. 1 kilogram is steam is taken.
No, it is I haven't assumed na, it is given 900 kilojoule per kg. Directly in the problem they have given na. Correct?
Okay, sir.
Okay. Try this question first. Just read. Whoever not able to understand anything in this problem, raise hand. Accordingly, we will solve. If there would be 5-6 people, then we will start. Otherwise, we will be late.
Sir, will it be 2 bar?
Okay, let's see. Okay, we'll start. 1 kg of ideal gas at 1 bar, and this contained in the rigid. Okay, so anyone have did?
Yes, sir.
What is the answer?
Yes, sir. It is coming as 2 bar.
Okay. 1 kg of an ideal gas at 1 bar 300 Kelvin contained in a rigid it is asking. This keep in mind. Try to catch the keywords. Anywhere you are getting rigid means volume would be constant, and
Volume would be
perfectly insulated means heat transfer would be 0.
0. Yes.
The specific heat at constant volume CV is 0.75, and stirrer performs. Okay. Assume the container does not participate in final pressure. Okay. So from the first law of thermodynamics, what is del Q is equal to del U plus W, del W.
W.
So this would be 0 here because it is directly written here, and there are many types of works, right? So we whatever formulas we have derived, that is for the PdV work, right?
Yes.
Hello.
Yes, sir. Yes,
Ah.
sir.
So for the system, and another type of work are like electric work,
Flow work.
flow work somewhat comes under this only, PdV, because flow work is what, P into V, right? Getting or
Okay.
not getting?
Yes, sir. Yes, sir.
Flow work we cannot consider here. Good. And electric work and that stirrer work. Electric work means I square RT, right?
Yes, sir. Yes.
That heating will do, but because this is not reversible, so that's why they are coming in the separate category. So somewhere they are heating for the some resistor would be there, and they heat. So don't keep that in the heat part. Put that in the work part, right? So those mistakes you may commit. So keep that in mind. So electric work and stirrer work. Anyone can tell me how you can calculate stirrer work, because actually they have given here directly, but if they won't have they haven't given and they want to make one separate part of question, so how will you calculate? Anyone can give hint? If no, otherwise I will tell.
Sir, as for this equation, I used Q equal to del Q equal to del U plus W, and as it is mentioned that
No,
so
this question anyhow we will do, no issue. I am asking about how this 225 would may have come. If I would have asking like here electric work, they have written like electric work is this, so directly you put and start question solving question. But like I have given like this much current I am giving for this much resistance and for this much time, so you will calculating, right? I square RT.
yes, sir.
So for stirrer work, how you will calculate? That I am asking. Got my question?
Omega T.
Someone is telling what?
Power is equal to omega T.
Power is equal to
Omega into T.
okay. This you are asking about torque, right?
Yes.
Okay.
Sir, power into time.
No. That anyhow we would be multiplying with time later. So
मतलब जो work होगा स्टेलर वर्क power into time.
actually, what are the cause for this? There you have to rotate this. Let's suppose this is the fluid here, and this is the stirrer. And you would be rotating it, right? So stirrer would be rotating against the viscosity. So main coming here viscosity, and that comes under fluid actually, same problem. So it would be the merge of two problems, fluid and thermo. That's why I asked. So sometimes it may happen. So here they would be giving viscosity, and from their viscosity into you would have studied maybe I think del u by del y. This would be the shear stress, right?
Yes, sir.
And shear stress and multiplied with the area. If it is constant, then multiplied with area. Otherwise, it function of a radius, then integrate. Correct?
Yes, sir. Yes, sir.
Maybe many of you not get, but if not getting, let me know. So anyhow, you would be getting here means torque
Sir,
and
one thing I have to ask you. Which one you are telling that the multiplication with area d
shear stress you would be getting by this equation.
Oh yeah, shear stress. Yeah, now got it. Got it.
Shear stress and shear stress tau into multiply with area. Just I told, and get the force, and let force and force multiply force and where it is acting. So now you will be getting the torque and multiply how much rotation you are giving. So that way you are getting the power. Okay.
Sir, I want to ask a question. Sir, the area here will be the area of the blade.
What?
ब्लेड का जो सरफेस है वो उसका एरिया होगा ना ये यहाँ पर.
ये डिपेंड करता है। हाँ, इधर पे तो जैसे फॉर एग्जांपल हियर force whatever here it will change according to problem. I think that will take one problem, it would be better, but here we won't be taking. So if they ask like shear stress is uniform, so just simply multiply area, uniform everywhere, but sometimes variation would be there. So sometimes it is acting on the some mid of the plate, like it is strip. Generally we use to integrate, strip take and 2 pi r dr we will take and do. So but here it we need not to do, so we will directly, I just given some hint for that.
Okay, sir.
So the stirrer performs 225 kilojoule of work on gas. So it is the work done on the system, so it would be the negative, right? 225 work done will be negative, and this is the 0, heat transfer is 0, and mass it is already given 1 kg, and the del u is mcv delta t. Mcv is what? 0.75. Units keep in mind, because here we have written in the kilojoule, so you have to keep cv in kilojoule. Here it is written in joule per kg Kelvin. Cv into delta t.
Sir, why work done is negative, sir?
Because stirrer stirrer is this, and stirrer is giving doing work on the system, because stirrer is rotating and it is giving its energy to the gas, right?
Okay. Okay, sir.
Work done on the system we are taking negative, right now?
Yes, sir.
So that's why we have taken negative. So and final temperature will be T2 minus T1. Here minus. So I think T1 we knows. T1 is 300. 300 we can put. So here we can find T2, right? 0.75 T2 minus 300. 1 minute. T2 minus 300 is equal to 225. And now divide by 0.75 here. And T2 would be 300 comes here. Plus 300. How much would be T2?
600.
600 Kelvin. So initially temperature is 300 and now temperature is 600, and it is the rigid, means constant volume process. So for the, if volume is constant, then we know the temperature is proportional to the pressure, right? So if temperature got doubled, so pressure would also be got doubled. Is it okay to everyone, right? Initial one is 1 bar, here it is written. So final would be 2 bar. Correct or not?
Yes. Sir, I have one doubt, sir. So the vessel is insulated, so why can't we use like adiabatic PV power gamma equal to constant?
So from there, what will you do?
We can eliminate this equation. We can use P and T term in that form of gamma and equal to constant.
1 minute.
And
You tell me what are you, from start you tell. What are you saying?
sir, the vessel is insulated, so we can, there is one equation like P and T term in the form of gamma equal to constant.
PV to the power gamma is equal to constant, right? Then
So why can't we use that equation? Because we know P1 and T1, also we know T2, so we can calculate P from there.
you can do now. 1 minute.
But sir, we will get different pressure value.
You are saying like what? P no, like P2 by P1 is equal to V2 by, sorry, that you are saying like T2 by T1 is equal to P2 by P1 to the power gamma minus over 1 over gamma. That you are asking, right?
Yes, sir.
Okay. How you got this equation? PV to the power is equal to constant, and here we have put like PV is equal to MRT, and that we have 1 minute. Actually, from when I derived this equation, then one assumption is there: a process would be reversible, right? It is valid for only reversible and adiabatic process.
Yes, sir.
Huh? From this assumption only it has started, right?
Yes, sir.
And here, whenever electric work and stator work will come, then process is irreversible. That keep in mind one thing.
Okay, sir.
One answer
Thank
is
you.
for this. I think we are taking. Okay.
Sir, I want to ask a question that why, मतलब sir, हम कहते हैं ना work और heat are boundary phenomena. Sir, what does it mean?
Actually, work will transfer boundary phenomena means like it will cross the boundary. Boundary crossing means if a work is there means how can I say, if work, let PdV work. So let's suppose first boundary is this volume V1, and now volume will increase V2. So its boundary got expanded. So its boundary, a clear boundary means expansion is visible, right? So it is happening in boundary. That's why we may say like boundary phenomena. It's crossing the boundary. We can see, and
Sir,
and
flow.
that also it is written like now you have seen like it is boundary phenomena, but boundary may or may not be visible. That also written somewhere, right? Sometimes you will be able to see boundary, but sometimes you will not able to see boundary. Here, how you will see boundary stator work? Not able to see, right? Electric work you won't be able to see.
Okay, sir.
Hmm?
So, sir, may you give some example? Those are not boundary phenomena.
All for work and heat they used to say like it is boundary phenomena, and all that those like internal energy, everything you would take that we don't consider as boundary phenomena, right? So for heat and work you keep in mind like it is known as path functions. Actually they are asking for that. Huh?
सर इंटरनल एनर्जी भी तो एक बाउंड्री फिनोमेना हो गया क्योंकि बाउंड्री के अंदर हो रहा है, बाउंड्री से सेपरेट हो गया.
No, hi.
मतलब इंटरनल एनर्जी मतलब कि जो बाउंड्री मतलब जो
Internal energy, how you, what is internal energy? Internal is nothing, the energy of the molecules, like energy of the molecules, it is internal energy, correct?
इन अ गिवन मतलब कन्फाइंड स्पेस,
What?
एनर्जी ऑफ मॉलिक्यूल इन अ गिवन कन्फाइंड स्पेस.
Yeah.
अगर गिवन कन्फाइंड स्पेस है मतलब वही बाउंड्री है,
But
तो
it is
मतलब
energy associated with molecules. That keep main thing, na. So if energy associated molecules, then how you will defining the boundary for them? These are
Sir,
microscopic properties, right? So you can't ask.
सर
which phenomena are you talking about? I missed that term, sir. Could you please repeat it 1 second for me?
फिर which time?
Due to actually, which phenomena are you talking about? Actually, I missed that term due to my distorted network.
I'm saying like internal energy is basically microscopic phenomena. Huh? So here we are removing
Okay,
like
sir. Got it.
macroscopic part like kinetic energy, potential energy of the system. For the our that total will come in the energy part. Like energy is function of summation of U plus kinetic energy plus potential energy. Hmm. But generally what we do like our system keeps in the rest, and it is in the our ground state condition, not in the higher state. So potential and kinetic from reference we take a 0. So these are the macroscopic part, and for the macroscopic things we can see like it is boundary here, boundary is creating. For the microscopic things we cannot create boundary, right? It is the nanometer level thing. So how will you say? And whatever internal energy we are taking, that is for the only molecules, right? For the function of temperature we used to say ideal gas, and all these parts we have neglected here. So for internal energy you can't say like it is boundary. For boundary you can create boundary for the microscopic things, right? That my point is.
सर मैं मतलब इस तरीके से सोच रहा था कि एक कंफाइंड हम कंट्रोल वॉल्यूम ले रहे हैं तो उसके.
No, don't think much na, otherwise the problem will come.
ओके सर, मेरे को एक चीज पूछनी है सर, जो काइनेटिक थ्योरी ऑफ गैस है उसमें जो हम डिग्री ऑफ फ्रीडम से कुछ गामा निकालते हैं सर, वो भी इम्पोर्टेंट है.
That is not here much important. Here you have to keep in mind if a means helium it is given. So for you have to take gamma 1.66. How much? 1.667, right?
Yes, sir. Yes, sir.
Just to keep in mind, if monoatomic, then this. If diatomic or air, then simply 1.4. And
1.4.
if like methane, etc., then they will give. These are the polyatomic, right? So that time either they will give, other not given, then take 1.33. Otherwise, more than that, nothing needed. Huh?
Okay, sir. Okay. Thank you, sir.
Okay. Okay. I will start this question. How many of you able to solve? Actually, I will start along with you, and because we have to solve much more problems. So just you also try. If you, how many of you able to solve? Just raise your hands. Huh? And I will ask you and keep answering the data in between. Okay. Air is contained in a frictionless piston cylinder arrangement as shown in figure. So I think same problem we have done in the class, right? When we are doing. But at that time we have asked about what is the amount of this Q and work done. All of that at that time we have derived. So here we will quickly do. Atmospheric pressure is 100 kilopascal and initial pressure of the air in the cylinder is 105 kilopascal. The area of piston is this. Heat is now added to the piston and moves slowly from its initial position until the reaches to the stops. So can anyone explain which processes will be happening if someone remembers?
Sir, expansion.
Expansion it will.
Reversible expansion.
Constant pressure process.
Okay. From here to here, nothing is stopping. So when we are adding heat, so it will expand, right? So it would be the constant pressure process from here to here. Let's suppose this is first position, this is second, and this is the third. So from 1 to 2, let's suppose this is 1.
सर कांस्टेंट प्रेशर रिवर्सिबल एक्सपेंशन बोलेंगे इसको
बोल सकते हैं. Yeah, you can say any expansion you, if reverse process is reversible, then you can say any expansion is reversible expansion.
Okay.
And after that it is written like now heat is added and moves pressure slowly from initial position until it reaches stops. The spring constant for the linear spring is this much. So here linear spring is important, right? Because from here only we would know the how pressure is varying. So linear spring means, can anyone explain how to means get the how, what would be the shape of curve here? How will you get?
Sir, straight line, positive slope.
How that I'm asking now.
सर मतलब kv मतलब k एक सेकंड
Sir, kx is equal to constant.
Kx is force here, right? So how? This is
Sir,
pressure,
because
right?
it is linearly varying, na?
Yeah.
Yes, sir.
Here they have mentioned like it is linear spring. If it won't be linear, they have given some function here, then that you have to keep in mind. Here for force we would be writing that k is function of x and into x. Sorry, dx then we'll put and integrate from xi to xf, right? Hello. Here from here
Yes,
you
sir.
will be getting the force and p by f by dA. That would be the dp, right? Pressure. Then this pressure will increase integrate and then only we can draw the this draw the curve. But here it is constant, so it will constant anyhow. So this force we can easily get F, and if we divide this divide by the piston area is constant, K is constant, X next total compression of the spring is we know, so delta X we will be knowing, so all would be the constant, so final pressure we would be knowing, right? So variation is linear, and the final, what would be the final pressure from here? 1 minute. This is the 105 kilopascal. So now let's suppose this piston has came and touched this point. So at that point initial internal pressure would be the 105 kilopascal, right? This is right or not?
Yes sir, yes sir.
Yeah. So after that this spring, this would be compressing this spring, and reaction force would be giving to the this piston. So when this piston would be reaching here, then how much amount of the force this spring would be providing to the piston?
12.5 into 80.
12.5 into 80 Newton. How much it would be? 1000, I think so. So this much force it is giving, and we know the area. So pressure we can easily find. P average. How much would be the pressure? 1000 by 300, and in kilopascal we will be doing. So into 10 to the power 4 by 10 to the power 3. So how much it is coming? 100 by 3, right?
33.3.
3.33.
So this would be the additional pressure rise due to the spring force, right? And 105 would be the from inside, already it is there. So this is rising and till here and here. So this much rise is the 33.3 or 100 by 3, right?
सर इसका जो स्लोप होगा k by a square होगा ना?
That you can easily find na. That f is equal to kx k delta x, and pressure is what? P by a, k by a, and delta x, and you want p and v. So p is here, and to make v, multiply a both side. So p k by a square and into v. Yeah. So if we PV curve, and the slope would be the k by square, right?
Okay,
But
sir.
don't mug up those formula, otherwise some points would commit mistake. So this is okay, right? Hello.
Yes.
Yes.
So what would be the value of this delta V? Because both 8 centimeter and piston area is 300 is given. So this would be the, I think, 88 300 2400 into 10 to the power minus 6 meter cube, right?
Sir, delta V means area of the piston and displacement.
No, area this volume means in order to reach piston from here to this place, how much volume it has swept, because this
Yes,
is the
sir.
first position is this from here to here.
Yes sir. Means swept volume into the area of the piston, isn't it sir?
No, swept volume mean no swept volume. Swept distance is 8 centimeter, right? And volume would be the distance into area.
Yeah, okay sir. Okay.
Like this it is, right? This is, let's suppose this is the area, and whatever 8 is given, 8 is this length, right? And this area is given to you is 300, right? So what would be this volume? 300 into 8, right?
Yes sir.
Hello.
Yes sir. Yes sir. Yes sir.
Yes, sir.
Yes, sir.
So it would be the 240, not 2400, I think. 300 into 8, right? And the volume is 300 into 8 centimeter.
Correct. 2400.
Oh, 2400, sorry. So in meter cube, it would be also the same, right? 2400 into 10 to the power minus 6. So you have to find the work interaction in joule. So simply find the area under the curve, correct? We know all the values here. That's why I'm asking. Area under the curve is the net work done, right? Hello.
Yes.
So here to here, 1, 2, 3. 3 areas there. So find the area of all 3 and simply add. So for 1, this is the 105 kilopascal. So 1 and 2, area of 1 to 2. Simply we can write 105 into, this is 2400 into 10 to power minus 6. So simply this is also 2400 into 10 to power minus 6 because it is also swept to 8. So how much it would be? 2400 into 10 to the power minus 6 into 2, because 2 times same area, this and this. So this would be the work done for this to this, and this is simple a triangle, and area of 3 would be 1 by 2. Base would be this, base would be this only, 2400 into 10 to power minus 6, and this perpendicular would be from here to here, and this we have found 10 to 100 by 3. So it would be the 100 by 3, because for pressure we have taken in the kilopascal and volume here we have taken in the meter cube. So answer would be coming into the in kilojoule, right? Hello.
Yes, sir. The total interaction is 500 kilojoule. 500 joule.
So find this answer first. It would be the kilojoule. So simply answer we have to find in joule. So multiply by 1000 also.
0.504.
1000. Now let me do the value. For first, how much it is coming?
504.
And for second, how much it is coming?
4.
What?
4 sir, 4.
Only
नहीं
4.
40 आ रहा है, 40 आ रहा है, टोटल 544 आ रहा है.
40 here, right?
Yes sir.
So total work done would be 504 plus 40. W total. Anyone also just confirm this answer? I think it is correct.
Sir, I have a doubt. Here atmospheric pressure is given and
Yeah, yeah.
internal pressure is also given. Then there will be a resultant pressure. That will be a 5 kilopascal which is acting upward direction. By multiplying the area of the piston and the displacement, we can calculate the work from 1 to 2.
What are you saying? Like you are saying external pressure is 100 already, huh?
Yes, sir.
So we are not considering that, we are saying, right?
Yes, sir. Since it is given in question, so we can consider it now.
Actually, 1 minute. Actually, this is given just for the reference actually here, na. So they are saying like it pressure in internal pressure is more than this, so it will go up. That's why just nothing or no use of that. Because actually I haven't given you the when we are doing the force balance here, because these equations I have directly written here. So but why this equation is coming by the force balance, because here we take p into a and from the bottom side and it will get cancelled. I think I should do again this. Otherwise I will put that that one image here. You can easily see like atmospheric pressure will got cancelled in same problem when we are calculating now, because that pressure is every time there. 1 minute. Okay, after solving the remaining problem I will put that slide here, I will take the picture of that and put here.
Okay, sir. Okay.
Simply that force balance equation I need to put, and force balance equation is there. So 3 times they are taking force balance there. So after that, this pressure will get cancelled.
Sir,
So,
if
sir,
there is a
in
pressure difference,
What?
if there is a pressure difference, then why the from 1 to 2 pressure is constant? Why it does not equal to atmospheric pressure?
No. Which pressure is expanding this piston? Not atmospheric, na. Uh, Internally here it is 105 kPa. So
Yes,
this
sir.
pressure is giving push to this piston. So this resistance from other side is same. So this will push. Otherwise external resistance will come. Same pressure would become. Same pressure would be
Sir,
there.
but if there is more pressure from one side and less pressure on the other side, then why it is not getting equal, sir?
You are saying
It,
how it will equal, because
when
atmospheric pressure will always be 100, right?
yes, sir, it should decrease. I mean, the internal pressure if there is a pressure difference.
You are saying because but we are adding heat now. Heat will also have impact. What heat just simply give energy to the internal molecules, and internal molecule will, what they will do, what there is
Temperature will increase and
temperature increase means
pressure.
temperature increase means its motion will increase, means run faster and collides. What when collision will happen, pressure will increase, but pressure increases, but at the same time it will go up, because there is no resistance, because here pressure will increase, and what is there. So just if we are not that same example I can whatever the other person is telling. So this is the answer for that. So 1 minute. So initially what is there, some piston is also having some mass, let's suppose. And this piston and this pressure, and from here piston mass means some, it will also be having some mg, right?
Yes.
Correct. So mg and this external pressure 100 kilopascal, and multiplied with this area, this will also have some force, right?
Yes, sir.
100 and this mg, and from downside 105 into area, that would be the balanced initially. And when this heat will be adding, so then force from downside would be the more, correct, because pressure increases. Hello.
Yes, sir.
When pressure increase, force would be more. Force would be more, then what it will try to do, it will go up and try to maintain the same force balance 105 to 100, right? Because that extra 5 kilopascal into this area, it is maintaining the weight of this piston, right?
Okay, okay.
So
Yes, sir, got it.
this is the actual region. So that person is asking, right?
Yes.
Yes, sir. From here we can conclude that whenever there is an atmospheric pressure is given and also weight of the piston is given, we can neglect that.
Because that is because anyhow from downside it is managing that also, na, this giving doing the work resistant opposite to that, because
Okay, okay.
you can see like this is the force 100 let's suppose this is the balloon and 100 is outside, and if something is happening from downside and it is here, so what we have, anyhow we have did the work pdb opposite to that 100, right?
Yes,
Getting
sir.
or not getting? So same thing happened here, so that's why we can't neglect. Now okay, got the answer, right?
Yes, sir. Yes.
Sir, ये 100/3 kilopascal is the difference in initial and final pressure?
Yeah, from here to here, because after this only this spring has came, right? After this point,
Okay.
till here to here, this is. Any other doubt? Should I go forward, right?
Yes, sir.
This is simple problem you can do, right? 2020 it has came, right? Entropy function of pressure and temperature for this problem. So what is the formula for that?
CV ln T2 by T1. CP ln T2 by T1. Yes.
Next.
Plus minus R ln P2 by P1. Yeah, P1.
So all we know here, pressure, temperature, and here we don't know CP here, right? Hello.
Yes, sir, we can get that.
Easily, because R and gamma you know, so CP you can easily get. Gamma is equal to CP by CB. And CB, sorry. This way also, but CP is gamma R over gamma minus 1. This you can use. But anyhow, these are the properties of air, so you would be knowing, right? CP is 0.718. But if it is not air, then you have to use this formula, correct?
Yes.
So you can easily get what is the value it is coming? Anyone?
So minus 26.33.
This one, right?
Yes, sir.
Any other person? Same answer, right? Hello. Anyone did or not? Or trying?
Yes, sir, I did.
Yes, sir. Option A. Option A is correct.
Yes, sir, option A is correct.
Okay. So, okay, this problem we will do. Just read this problem. Anyone able to? Because this is the till now it is coming in a special case of this is coming usually come in the gate. So this time they have changed a bit.
Sir,
Okay.
that seems like the previous we did, like the rigid tank of volume,
No, no,
like that.
this
No.
part I have skipped that point. So today I was seeing like it is we have to do this, huh?
Okay, okay, sir.
It is the last year gate problem also. So that's why. So here is the filling up tank. You see, I will solve. So a rigid tank of volume 8 meter cube is being filled up by the air from the pipeline connected through a valve. Initially, the valve is closed and tank is assumed to be the completely evacuated. Valve is closed, tank is this important. Completely evacuated means nothing is inside the tank initially, and the air pressure and temperature inside the pipeline is are maintained at this. Means, for example, this is the pipeline. Here pressure is 600 kPa and the temperature is 306 Kelvin. So from here one valve is there. So here one container, let's suppose this tank. This is the tank, okay. So initially nothing is here and we will open this valve and this say this is reservoir, this pipeline. Nothing will change if something coming from here to here, right? This keep in mind. So filling up the tank begins by opening the valve and the process filling up the tank. This is the tank what we are considering. Filling up tank begins opening the valve and the process ends when the tank pressure is equal to the pipeline pressure. So when it will because it will come here because here pressure is less when it will open, so it will suddenly coming here, but when pressure will be the same as the pipeline, so it will stop, right? And we will stop the this valve and take it. Filling of tank begins during the filling process heat loss to the surrounding is 100 kilojoule. heat loss to the surrounding is 100 kilojoule. Till now whatever coming to the gate is like heat loss to the surrounding is insulated, means 0. That becomes the special case. So that time simply one formula is there, Tf is equal to gamma times of Ti. Simply we used to learn this formula and the answer is done. Ti means temperature at the pipeline. If it is evacuated, that we will see like later it will directly come. And one problem I think in 2020 or so it has came like gamma Ti only. And last year it has came like they have given heat transfer to the surrounding is 1000. Okay, got the problem what I'm saying? Hello.
Yes, sir.
There we go.
So here what we have to do, first I will tell you just 1 minute. If anyone knows like how to proceed, then let me know, otherwise I will proceed. Anyone knows?
Yes, sir. We will apply the steady flow energy equation, not a steady flow, flow energy equation. That will be delta W net minus delta Q net plus M2 minus M1 multiplied by HP plus VP square by 2 plus GZ is equal to 0.
So what will you get from that equation?
So from there we will get the temperature.
But sir, I don't know the mass that will enter. Sir, how we can calculate that?
1 minute, your voice is breaking. What are you saying? Noted.
Mass of the air that is being entered into the tank.
What I will do, like I will first go by generalized way and then we'll simply put the values. Okay. So for the this is like one type of open system here, correct? Because from here some mass is coming and some mass is, let's suppose this is our control volume. This is correct. And some mass would be coming inside and no mass from this is going outside, right? Because it is completely sealed. So M exit is 0. That keep in mind. So some mass would be coming. That is for sure. So for the open system we have to do only two things. One is the mass balance and one is the energy balance. For the mass balance, let's suppose this boundary is our control volume. So rate of change of mass inside the control volume is rate of incoming mass and rate of minus of outgoing mass. Is it okay? And nothing is going outside, so it would be 0. Correct?
Yes, sir.
So let's suppose this is equation 1. And now coming to the energy balance. That from start I am doing because now let's suppose this time they will add some pipe here and some mass would be going out. So that will be the next problem, correct? So energy balance we will do. Energy balance this is now for now it is like a closed system. So internal energy change du for the control volume, rate of change of internal energy of the control volume. So how energy inside the system would be changing? 1 minute. Oh. So whatever amount of, let's suppose initially it is evacuated for this problem. Let's suppose something is there initially also. That will also take into consideration. But let's suppose this from here mi it is coming, let's suppose. So mi and whatever the enthalpy of this, that will be mi into hi. This is coming to the system, right? So this is positive. If anywhere someone doubt, let me know. This is positive. And let's suppose we are giving heat to the system, but here going out, so that will come negative. But for example, heat given to the system, we will take it positive. Two things would be coming. First, mass inlet coming to the system and heat given to the system. And next, work done by the system control volume means it is for control volume. So work done by the control volume means it would be the done by the control volume, so it would be negative. Is it okay to everyone, right?
Yes, sir. Yes, sir.
And minus, let's suppose ME is the mass going outside of control volume, ME into HE, because here nothing is going out. If some point of time it will go out, so that this part would be coming. So here what is, this is the rigid, it is not expanding. If it is, let's suppose this is balloon, so its volume will also be increasing, right? Now it is rigid, so it is fine, rigid tank. If it is balloon, then work done would be there, right? So that part also will come some point of time. Getting or not getting?
Yes, sir. Got it. Got it. Got it.
So for here, for our this problem, this work done would be 0, and this part also would be 0. But these any one of these may come, right? This is correct or not?
Yes, sir. Yes, sir.
So this is our second equation. Till now what is happening, like they used to say like it is insulated, so this is also 0, but here it is not 0 because it is given like it is 1000 here, right? Hello. Hello.
Yes, sir. Yes.
Okay. In second equation now, m dot I is what? This rate of change of mass inside the control volume. From in equation to from equation we can easily put, right? This. Hello.
Yes, sir. We can put.
So, sorry. duCV by dt is equal to mi is what, and d of m inside the control volume, rate of change of mass in the control volume, into hi. Hi is what, anyone? CPTI means enthalpy of the this pipeline, air is na, pipeline air, plus q. So simply this multiply dt here, so it would be, so this would be the constant because it is the same here, and into this into dt plus q into dt, right? Let's suppose q dot means per unit time, right? So now integrate that part, you see, sorry, dCV from initial to final, and here dt will get cancelled, and hi is constant, and change in mass in the control volume. So change in mass in the control volume, initially what would be the mf minus mi? What is mi? What is the meaning of dmcv? Anyone? Its meaning is like change in the mass inside the control volume. Inside the control volume means initially how much mass is there? Nothing, evacuated, right? Hello.
Mi equal to 0, sir.
So mi would be 0, but that also we like, it will say like initially pressure is something, volume is something, and temperature is something. So mi will also come that point, right? Got this point?
Yes.
So these are the variation I am telling. In one problem, lot of variation are possible here. So those keep in mind. Anytime it will. That's why I can easily solve this problem, but I want to show all these variations. Okay. So that's
Sir, is the answer for this is 387 Kelvin?
I don't know the answer actually. So it would come like, let's see whatever is coming. Answer is not important here. So I'm saying like these things to keep in mind. So q dot dt means q dot is rate of transfer of heat from the control volume, and tt is the whole time. So here they have provided like total heat whatever it is given to the surrounding in whole time. So here directly we can write this. So q we will write. And what is the change in internal energy of the control volume?
mcvtf.
Means m let's suppose finally we will write internal energy at the final stage minus internal energy in the initially, and initially no mass is there inside, so this internal energy is 0. So what would be the UF? 1 minute. What is the UF? UF means final internal energy inside the tank, means MF and into CV into TF, right? Hello.
Yes,
Yes,
sir.
sir.
So MF we can easily find, right? What would be the value of MF? Hello.
Cell density into volume.
How will you find density here?
CV by RT.
PV is equal to MRT, in which we will use the pressure and temperature of the pipeline.
So from here easily you can find, right? PV by RT using the pipeline means initial condition, right? But volume would be how much? Volume would be this tank volume, right? Because that much volume it will be considering, right? Or not?
Yes.
Hello.
Yes, sir.
So calculate mass from here, and CV we knows, and mass we would be knowing from here, and Q is heat loss to the surrounding is 1000 kilojoules. So minus 1000 we will do, right? Hello.
Yes, sir. Yes, sir.
Yes,
And
sir.
HI would be the M. M we would be knowing from here. HI would be the CP into
T,
TI.
T.
TI is written, I think, 306. Everything knows, right? And only here TF is unknown. Correct or not? Hello.
Yes, sir.
Yes, yes, sir.
Yes, sir.
So I think you can calculate now. TI is known, MF is known, and plus Q is also known. Correct? Got it or not? Hello.
Got it.
Yes, sir. Got it.
Okay, then find the TF and for the next class, I think. Let's see how many problems are coming.
395 approximately something, sir.
Yeah. And easily you can see, like if it is insulated, you can keep that as 0, and here UF CV will come, MF will cancel out from both sides, and CP by CV, TF would be gamma TI, right?
जी सर जी
Yes,
सर
sir. Yes.
Easily you can see here. So this you keep.
सर एक बार इसका आंसर कंफर्म हो जाता.
Two people, whatever two three people have did. Actually, I don't have calculated. So we have
395.39.
Is it yours also?
मेरा 387 आ रहा है सर, तो अप्रोक्सीमेटली सही है.
Okay, because if it would be more wrong, then answer would be different, no? So it is correct, I think. Some calculation mistakes and value would be here and there. Okay. So do this problem, and next we will do in the next class. This is also good problem. Just see once and then we'll start. Just let me know the answers. 1 minute I will wait and see.
Sir, for this problem, should we assume that the entropy generated generation is zero, right, sir?
You just try it, then we'll see what you are thinking. Like that, I want to see. Here, keep this word in mind. Look, expand reversibly.
Yes, sir. So therefore, the entropy would be zero.
Sir, answer is 500 megawatt.
Sir, 4.5 into 10 to the power 9 are.
What unit? Megawatt. Yes. This is
Yeah, yes, sir. Yes, sir.
it won't be, I think. Okay. This is the first and this is the second case. 500. You have committed a mistake. No? I think so.
Sir, I forgot take heat due to this entropy.
Okay. So because actually whatever we are considering, what assumption here from 1 to 2 turbine? Anyone knows? Let me know. Assumption.
So as the system is reversible, therefore the entropy generation will be zero. And
first one
And
is
it is
here also
also
irreversible, and this main here is adiabatic. Huh?
adiabatic, yes, sir.
This is main important thing here.
Yes, sir.
Here whatever they are considering, it is not adiabatic. Huh? Otherwise they have to write. It is not adiabatic. This is just reversible. Huh? So reversible means adiabatic is not there. So heat transfer would be there from a system. Okay. Sorry. Oh. So from first position, what is the enthalpy? 3500 and entropy 6.5. And here at the second position, entropy is enthalpy is 2500 and entropy is 6.3.
6.3, yes.
So let's suppose for the reversible process, entropy generation from the whole system, entropy generation from the universe. Okay, entropy generation in the whole universe would be 0, correct? Entropy for the whole universe. So for the system, let's suppose system here from 1 to 2 it has came. For the 1 means it this much entropy has given to the system. So mass of the system is 500 because entropy is in the kilojoule per kg Kelvin. So initially it is 6.5, and when it coming out of the system, that time entropy is 6.3. So this much entropy is associated with the incoming and outgoing of the fluid, means steam. So this much entropy should be compensated by the transaction of the heat, correct or not?
Correct, sir.
So that much heat transfer will be taking place, otherwise entropy generation is there. So let's suppose q amount of transfer of heat is happening, and heat loss occurs reversibly at a turbine at a temperature of 500 Kelvin. So temperature they have considering average temperature is 500 there. So you can easily find here, right? It is 0. How much it is coming?
So that is coming 4.5 10 to the power 6, right, sir?
Your voice voice is breaking actually. How much it would be coming? 0.2 into 500? 100, right?
50 megawatt QR, sir.
It would be the 100 kilojoule plus Q by 500. So we would take that this side minus, it would be the minus, let's suppose, Q by 500, and 500 would be multiplied here. So it is the kilojoule. So convert that to mega, 30 bit gone, minus 500.
सर 50 मेगावाट आ रहा है
50. 50. Okay. So 50 megawatt would be the heat transfer, right? This is the important part here. If you missed that, then otherwise answer would be wrong. So now coming to the what would be the steady flow energy equation for the turbine. Let's suppose this is the turbine. Let's suppose coming here, going there. 1, 2.
mh1 equal to mh2 plus q plus w.
So let's suppose here q is the heat transfer, and 1 is incoming, 2 is outgoing, and here it is the w net.
Q plus mi hi equal to
So what would be the steady flow energy equation here?
Q plus mi hi equal to me he
mi h m1 h1 next plus q
plus Q
is
equal
equal
to
to m2 h2
plus W.
plus w. So m1 h1 is 500, h1 is 2500.
Yes, sir.
Q would be the minus 50, but unit would be the same here, right?
Yes, sir.
So megawatt we will convert to the kilojoule. So 50, 1, 2, 3.
Sir, if we don't convert it on kilojoule, if we keep the unit same, then what problem would it be?
Same thing will come, but you have to keep in
yes,
mind
sir.
everywhere would should be same. Otherwise, some mistake will you do.
Yes, because
500 and here 2500, and W will come. How much W is coming from here?
Sir, for 450 megawatt.
Anyone confirm this?
5 into 10 to the power 6, right, sir?
Huh? 4.5 into 10 to the power. No.
6.
It would be into 10 to the power minus 10 to the power 9 here. 6 is just the mega.
Sir, I don't know why my
8
answer
would
is
come.
coming
For
like
the watt,
this.
it would come like this.
Okay. Yes, sir. Yes, sir. I made some mistake. Yes, sir. Yes, sir. Got it.
Is it okay, everyone, right?
Yes, sir. Yes, sir. That will be 450. 450.
This VCRS problem we can do, but in RSC it would be better, so we will do that time. These 3 problems we will do quickly, and then we'll wind up. So this same problem we have did in the last class, properties of pure substance, right? So a tank is having some volume, contains pure substance, mixture of 80% of vapor and remaining saturated liquid, means remaining 20% is liquid. And the properties at the saturated pressure are given below. Vf they have given, Vg they have given, then we have to find the total mass of the system. Easily find, you can find, right?
Yes, sir, it's easy.
So let's suppose total mass is m. So 80% is vapor. So mv would be the 0.8 m, right? And mf is 0.2 m. So mf, these two things we know, and vf and vg we know. Simply multiply mf with vf and mg with, sorry, we will write as mg. Mg with Vg, and add this and make this as 50. You can easily get the answer, right? Value of m. If anyone is not getting, let me know. Hello.
So 135 kg.
Simple calculation, it would be around that only. Yeah. Anyone calculate, confirm this? It would be same. Mg put 0.8 m, mf is 0.2 m, and simply put here, right? Mf, mg, vf you know, vg you know. Hello.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Doing, sir. Yes, sir. That is coming 135.08. First one.
Should I wait or go forward then? I think I have written everything.
Yes, sir.
Next question, sir.
Yes, sir. Yes, sir.
So what is the compressibility factor Z? PV is equal to MRT. Whatever it is coming, it is Z. Okay. So here in GATE 2021 it has came like superheated steam. Steam you can consider as perfect gas, not ideal gas. So some equations are valid. So because after that no phase change would be there, na? So gas is there only, gas. So they are considering it will follow. It will not follow ideally because for ideal gas compressibility factor would be 1, and here it is 0.95, right? So superheated steam pressure they have given, and volume, specific volume, it is small v is there, so specific volume. Specific volume means mass, volume per unit mass, right? Like that way, but it is not so, it is kilomole, so keep in that in mind. I have told you first day na, what is the difference between PV is equal to MRT and NRT?
Ji sir, ji sir.
So that keep in mind, otherwise it will go wrong. So V and compressibility factor Z, and find the temperature of the steam in degree Celsius. So pressure you know 1500 kilopascal, and volume you know 2.75 meter cube kilomole. Here you know kilomole. If it is kg, then we would be writing R of that superheated steam. But here it in kilomole, so it would be the universal gas constant, right? Hello.
Ji sir, ji sir.
And mass is 1 because it is specific. So mass would be 1, R would be 8.314, and Z it is given in the problem 0.95, and temperature you can easily find from here. Whatever it is coming, it would be coming in the Kelvin, so convert that to the degree Celsius, it would be the answer. Anyone problem? Let me know.
Sir, वैसे specific.
No, sir.
Sir, specific gas constant for vapor is 0.462.
Nothing like that, because it will vary with pressure to pressure, so it should be given.
Sir, specific gas constant.
For vapor it will vary from pressure to pressure, na? For this is different pressure, this is the different pressure, this is the different pressure. For every it is different. Here it would be different, here it would be different, here it would be different. So we cannot define one value.
Sir, specific gas constant पूछ रहा था मैं, जो R by M molar mass होता है वो वाला.
अच्छा, that you are asking. Universal gas constant you are saying.
सर स्पेसिफिक गैस कांस्टेंट जो होता है, यूनिवर्सल गैस कांस्टेंट बटे m जो करते हैं, m यहाँ पर kg में लेंगे या फिर हम ग्राम में लेंगे?
M need not to take, no? because it is specific volume.
सर मतलब R by M करते हैं ना?
You are committing mistake here.
8.314 by 18 करेंगे सर?
No, not like that. Here what, why they have given kilomole?
सर मतलब वो मेरा मतलब वो बन गया ना पैटर्न की V को बाय केजी में ले लेता हूँ मीटर क्यूब बाय केजी, तो उस तरीके से सोच रहा था।
No, so in that case na, that they have to give the value of M, R also, and many in whatever then problem they have did given, so that way you have to go. Huh?
Okay sir, okay.
So in kilomole they have given, so for you have to use the formula of kilomole. R value of R bar would be the because here what would be the value of P into V unit kilopascal, and that pascal and meter cube will be kilojoule per kilomole, right?
जी सर.
So in upon also na, same unit would come, same unit from where it will come, mole from here it will come, right?
Okay sir. Sir, 552 Kelvin.
Convert that to degree Celsius and it will come. Hello.
I'm getting 249 Celsius.
What in Kelvin? How much it is coming? 5.
22.
524.26.
Sir, I am getting 522.
And in degree Celsius, when someone is telling what is?
249.
49.1.
So it is seems okay. So it would be correct, right? So this is the one another problem from the PT curve. That is also good question. So PT curve, it is like this, right? This way, this way, this way. So here it would be, sorry, solid, liquid, and here would be vapor. So like question for the liquid vapor boundary means this one, right?
Yes, sir.
Liquid vapor boundary, this equation is, and the solid vapor boundary. Solid vapor means this boundary. Equation for the both liquid vapor boundary and the solid vapor boundary in the PT curve is given by the following expressions. So first expression is this. This is for the which liquid plus vapor boundary, right? Respectively written. So and here it is solid plus vapor. So final temperature of the find the temperature of the triple point. So at the triple point, this is the equation and here it is the equation. At the triple point, its temperature of the both and pressure of the both would be the same, correct? Hello.
Yes, sir. Yes, sir. Yes, sir.
So here they are asking for the temperature. So we would simply equate these both equation, eliminate
Both
pressure
equation,
and
yes, sir.
and if they are asking for the triple point pressure, simply eliminate the temperature and find the pressure, correct?
Okay.
So whatever they are asking, you can easily find, right? Just simply do.
Sir, go. Huh? Yes, sir. Done, sir, already.
So let me the value. What is the value? It is
Minus 30.
What?
Yes.
Kelvin, tell Kelvin how much?
195.197 Kelvin.
Correct, right? Others also getting same, right?
235 आ रहा था मेरा.
195 Kelvin.
Just 235, just see again, and might be it is correct.
हाँ जी सर, अब सही आ रहा.
Sir, sir, when will we get the videos, actually the recorded lecture series, that if we face some problems then we could rewind?
Actually, no, for it would be uploaded. I think actually we have given our Google Drive link for the all videos, but now they send me like you upload in the YouTube, and the YouTube link we have to provide. So
Okay, sir.
that's why it is got delaying. So, but for this
Yes, sir.
2 3 classes, I forgot to record. So it is
Yes, sir. As sir, I have followed that for metallurgy and for rest of the class already. It's been provided, so therefore I was asking you.
there what how they are doing in uploading in the YouTube, right?
Yes, sir. Yes, sir. They have provided the recorded link, and it's like all of the things we could
So
follow.
for the Google Drive link, they are providing or YouTube link?
YouTube link, sir. YouTube link.
Okay. So who are teaching? They are providing link or send the portal they have given? That I'm asking.
Sir, actually,
The portal itself.
portal is it's open.
Okay. So that would be done by the NPTEL team. Okay, then we have to upload. And okay, this problem we will do and then stop. Just read this problem. It is just I will quickly give the hint and we'll stop, right? So and try, and let's see in the next class. Air enters a perfectly insulated compressor at a temperature of this, pressure ratio is 6, specific heat constant pressure. Just read once, then we'll start. Okay.
सर हम रिकॉर्डेड वीडियो कहाँ से देख सकते हैं?
That in the portal they will be providing link soon. Okay. From where you are joining class right now, na? So there only it will come.
सर इट्स अवेलेबल तो नहीं दिखा रहा है.
अभी
सर हाउ
as of
टू
now it won't be there. So message. Okay. So in this problem, there is a compressor, so it is compressing. Let's suppose this is the P1, and the next pressure is P2. So P2 and P2 by P1 is 6. Correct?
Yes, sir.
So
yes, sir.
let's suppose it is compressing reversibly from 1 to 2, but it is not so, because it is given like assume the specific heat constant if the isentropic efficiency of the compressor is 85%. Means if it is isentropic, then it would be the S1 is equal to S2. Means this would be the same. But isentropic efficiency means it is irreversible process, like this 2 dash. So what is the isentropic efficiency of the compressor? Anyone?
W isentropic expansion by W actual, meaning H2 minus H1 by the result we will get
Is it so?
Yes, sir.
Is it so?
Sir,
Yes,
would you
sir. Yes,
calculate?
sir.
Yes, sir. Yes, sir.
Same, because you have to keep in mind, like simply you have to make it less than 1. So for the compressors, you want to, and it would be the irreversible process. For compressor, we have to give the work. So this will work done to for irreversible process would be more. So it will go this way. And for efficiency, it should be less than 1. So value of 2 dash would be more than the 2. So it's h2 minus h1 would be less, and h2 dash minus h1 would be the more. So simply efficiency is for the if theoretical way we want to write, then work input for the reversible process, reversible compression you can say, by work input for the irreversible expansion, irreversible process, right?
Yes, sir.
So simply that's it. And similarly you can write for turbine also, right? Let's suppose here one turbine is there. It is not so, but I am doing. So one turbine is there. So irreversibly it would be like this, because irreversible process entropy always increases, right? That way also you can think of. So here let's suppose it is 3, it is 4, it is 4 dash. So here what would be the formula here? H4 dash minus H3 by H4 minus H3, right?
Yes, sir.
So how? Simply because in if it would be reversible, you would be getting more work. If irreversible, you will be getting less work. So simply
Yes, sir.
W output by irreversible by the W output by reversible, right? So this is just simply you know everything. I think most of the things you would be knowing here, because it is ideal gas. So enthalpy would be the simply CPT, right? Hello.
Yes, sir. CPT means CPT2 minus T1, right, sir?
No, for enthalpy term I am writing. So whenever
Oh, okay.
T2 H1 it will come, accordingly temperature will come. So isentropic that
Got
isentropic
it, sir.
efficiency is 0.85, right? 0.85, and H2 minus H1 means T2 minus T1 by T2 dash minus T1. So in this problem T1 I think it is given. T1 is how much? T1 is 310 Kelvin, right?
Sir.
T1 is known, and T2 you can simply find, because it is simply we have
Yes, sir.
reversibly compressed, reversibly adiabatic, because entropy is 0. So T2 by T1 is equal to P2 by
P2
P1.
by P1 gamma minus 1 by gamma.
Yeah. So value of P2 by P1 is RP. RP is 6. So 6 to the power 1, sorry, 0.4 by 1.4, and simply multiply this T1 here into T1. So T2 you will be getting from here in Kelvin, and put the value of T2 from here to here, and T1 you knows already. Put T1 here, and 0.85 you knows, and find the T2 from here, T2 dash from here, right? Getting or not getting?
Yes, sir. Got it. Sir.
So what will be the enthalpy difference? What in question it is asked, difference in the enthalpies of air between exit and the inlet of compressor. So exit is what? H2 dash, and inlet is
H2 dash.
So
H1.
simply in kilojoule you have to write. So 1.005 T2 dash minus T1. T1 we knows 310, and T2 dash we would be knowing from here. So value would come something.
So 244.7.
Yes, exactly.
How much?
244.7.
Okay, it would be like that. Okay, remaining next class we will try to, because as of now in this class I tried to took some problem from the first law of thermodynamics and properties of pure substance. So next class we will try to take second law of thermodynamics and other problems. And whatever remaining.
So can you share your drive link?
Actually, I saw last time someone had deleted that PPT. So I think I have to remove the editing right and only view what I have to do.
So could you please provide the drive link with all the weak notes, sir? Then we can further practice the questions in future also.